We're going to have a look at some special angles in trig. It makes it easier for us just to remember some of these, especially when we're working out exact values and calculations. So we're going to have a look at how they're derived. We're going to start off with an equilateral triangle. Equilateral triangle obviously has angles of 60 degrees. It makes it nicer if I've got a side of 2. That way, when I chop it straight down the middle, that base section has got a width of 1. So I've got a side of 2 on the hypotenuse, 1 on the short side, an angle of 60. Pythagoras tells us that that missing side is 2 squared minus 1 squared, 3, and then square root it, so it's root 3. We can have a look at our normal kind of SOHCAHTOA way of looking at things. Sine 60 is opposite over hypotenuse, so that gives me root 3 over 2. Cos 60, adjacent over hypotenuse, is 1 over 2. Tan 60, opposite over adjacent, root 3 over 1, root 3. Considering the 30 degree angle, sine 30, opposite over hypotenuse, 1 over 2. Cos 30, root 3 over 2. And tan 30, 1 over root 3. The other type of triangle we're going to look at is a right isosceles triangle. That means it's an isosceles, so both the sides are 1, but it also contains a right angle. If you consider this, it has to have an angle of 45 because it's isosceles, both of them have to be the same, so it's the 90 split. Pythagoras tells us side of 1, the other side has to be root 2. 1 squared plus 1 squared is root 2 squared. Much easier to consider this. Sine of 45, opposite over hypotenuse, 1 over root 2. Cos 45, adjacent over hypotenuse, 1 over root 2. Tan 45, opposite over adjacent, 1 over 1 is just 1. Putting all that together in a nice kind of table we can appreciate and filling in some extra values, we're going to see that sine of 0 is going to be 0. We'll look at that from the graph point of view somewhere else. Sine of 30 is a half, sine of 45 is 1 over root 2, sine of 60 is root 3 over 2, and sine of 90 is 1. I prefer to write sine of 45 as 1 over root 2. Some people like to rationalise the denominator, make it root 2 over 2. That way you can get a nice kind of pattern running along there. You've got root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. But I find it easy enough just to remember them kind of quirky numbers. Cos, exactly the same idea running backwards, because in a right angle triangle, cos of one angle is the sine of the other angle, if you think about it. And tan, we're just going to use the tan is sine over cos kind of idea, filling in the bits that we know. And tan, we've got tan of 0 is 0, again we'll see that from the graph. Tan of 30, 1 over root 3, tan of 45, 1, tan of 60, root 3. But tan of 90 is undefined. Some people like to write infinity, I don't, I prefer undefined. And again with the tan of 30, 1 over root 3, some people like to write root 3 over 3. Not for me.